In this tutorial, we continue with our friction chapter. In the previous tutorials, we brought out how exactly the frictional forces would develop on horizontal surfaces or horizontal planes. When the movement is also parallel to horizontal planes, it is but natural for the friction force to develop on horizontal surfaces opposing the motion. And here we will discuss some of the practical situations wherein the frictional force is ought to develop on inclined surfaces. The car here is descending down the incline. If there were to be no friction between the tire and the road, this car would have tumbled or moved uncontrollably faster down the incline. And here, on the other hand, it requires huge amount of propelling force in order to make this jeep to move upwards, because there is a lot of friction that is involved. Okay, together with the weight, it's going to cause very dearly as far as movement of this particular jeep is concerned. And in an amusement park, we will see the slides, and here the friction is kept at a minimum level in order to avoid a kind of injuries. And here this particular truck laden with heavy weights is struggling to move upward because of the frictional resistance. And here we need an inclined plane. Here the friction along the incline or friction over the inclined surface has been usefully used in order to dump the goods. So there are several occasions wherein the friction becomes advantageous when things are moved over an incline, and disadvantageous sometimes. So this is very intriguing, and we should be able to explain as to why the bodies kept on an inclined plane tend to slide. And we can come out with a very simple example. And here is a weight, and this is the body, and this incline makes an angle of theta with respect to horizontal. Therefore, with respect to normal, the normal reaction will also make an angle theta, and here W will also make an angle with respect to the normal to the incline. And if we resolve this W, and here goes W cos theta vertically down, which is a causative factor for the development of normal reaction, while W sin theta is the horizontal component of this particular weight along the incline. And you can see the direction of this particular force, which is owing exclusively due to the weight, and it is towards the incline. Anyway, the direct W may not cause the movement because it is the block being supported. Therefore, it is only the component of W that is along the incline which is the cause for the movement. However, to a certain extent, we know this. This is how we developed the concept of angle of repose. And there is a particular inclination for a particular weight and for a particular surface. Anyway, sky is not the limit. Anyway, when it trends to slide, the frictional force will oppose to the extent that is possible. That means up to the limiting stage. And during that particular stage, this, though it is placed on an incline, it will enjoy being in equilibrium, right? And it could be measured something like this. Here is a measuring gauge, and we can notice how exactly this particular thing moves, and this is the angle of inclination, which can simply be equated to the angle of friction, and therefore coefficient of friction. Okay, the tan phi is also called as coefficient of friction. This we have studied in our very first tutorial itself as a fundamental. So we will go on tackling some of the problems of engineering interest, and in the melee we will try to understand as to how the frictional force and or estimation of frictional force or estimation of other parameters related to problems which are placed on an inclined plane will be discussed. And this comes as an example 8, which is a cumulative numbering, and as 7 examples we have tackled under the friction over horizontal surfaces. For the block shown in figure, find the force P required to push the block when P is push the block up, of course, is horizontal when P is horizontal and when P is parallel to the incline. So we will consider the first case when the P is horizontal. So this is horizontal, this line is horizontal, and this line makes an angle of 30 degree. Therefore this force will also make an angle of 30 degree with respect to the incline. And if we happen to write the free body diagram of this particular block, there is a weight which is acting down, and this is the normal reaction which is normal to this particular surface, and this is the frictional force because the direction of the movement is upwards. Therefore because this force is trying to make this particular block to move upwards, therefore the frictional force is like this, and it is 0.25 N because the frictional coefficient is given to be 0.25. And when you resolve the force P, it is P cos 30 which acts along the incline, parallel to the incline, and P sin 30 will be acting perpendicular to the incline. So this is the configuration of the force system acting on this particular block when this block, and we need to find out what is that force P which is required to cause a jerk along upward direction of the incline. So we will equate resolving the forces perpendicular to the incline. One important thing that is to be noticed in these kind of problems is we will always resolve the forces with respect to the incline itself, and along the incline and across the incline. The reason being the movement will happen along the incline, and it is not along the conventional horizontal axis. Therefore it's and we will find ease with which the problems could be solved by doing so. Here sigma f algebraic sum of all the perpendicular forces means all the algebraic sum of all the forces which are perpendicular to the plane of the incline. So in that sense, normal reaction comes, it's going up, therefore it is positive, minus 500 cos 30, that is 500 cos 30 acting along this particular line vertically downwards, minus P sin 30, this is the force which is acting vertically downwards. So that is equated to 0, and we will build up a relationship between N and P. N minus 0.5 P equal to 433.01, and we will keep this as equation 1 because still two unknowns remain. We need to seek another. We want to seek another equation in order to solve them. Resolving the forces along the inclined plane. If you just venture it once again, this is along the inclined plane, negative going left, and this is going positive. This also along the incline, and the component of 500 along the incline, which is also going downwards. Therefore it should be if this angle is 30 degree, it is 500 sin 30 going down, and P cos 30 going up, and 0.25 N coming down. So we will write that P cos 30, the component of P, minus 500 sin 30, the component of weight, minus 0.25 N, the frictional force. And if we simplify this, we boil down to 3.5 P minus N equal to 1000, and we will add equations 1 and 2. Okay, then we will get, because in the equation 1 we have made N to appear, therefore we will add it, and here N will cancel, and we will be left with 3P equal to 1433, therefore P equal to 477.67. So if the force is acting with an angle with respect to that means if it is acting horizontally, that means if it maintains some kind of an angle with respect to the inclined plane, the force P happens to be 477.67, which is sufficient enough to cause some kind of a disturbance, to cause some kind of a jerk along over the incline, that is opposing the incline, up the incline rather. And the second case is we will consider the free force P parallel to the incline. It is going like this, and here is the free body diagram. This is P and this is 0.25 n, and n other things will remain the same. So resolving the forces along the incline, that is sigma fx equal to 0 minus 0.25 n, that is P going positive rightward direction minus 0.25 n and minus 500 sine 30, the component of 500 Newton. And I think it's better we write down how exactly the component of the weight will act. Okay, and if this is the weight, and one of the components will be like this, which will be perpendicular to the incline. Other component will be like this, which is along the incline. This is 500. This is 500 sine 30. Okay, this is the causative factor for any body, any object that is being placed on inclined plane to show some kind of a tendency to move down the incline. So upon simplifying, we will get P minus 0.25 n equal to 250, and then resolving the forces across the incline, we will have n going up minus 500 cos 30, that is coming down, but perpendicular to the incline, should be equated to 0, and we will get n equal to 433.01. and if we substitute the value of n in the previous equation 1, we will get P into this thing, and simplified. Upon simplification, we will get 358.25. There is a very important thing to be noticed, my dear respected viewers, and here when the force is parallel to the incline, it has become lessened. It is as less as 358.25, while if the force is let us say parallel to the incline, is a horizontally acting, thereby causing an angle of 30 degree, the vertical component P sin theta of this force will add on to the weight. So vertical component of P will add on to the weight, which is going down. Therefore, the component of the weight across the incline, and this particular component will add on together, and thereby essentially it will increase the value of n, which is the reaction offered by the inclined plane, and therefore the frictional force will also be increased. So in order to overcome this frictional force, P has to be much more than the P if the P were to be placed horizontally, that is parallel to the incline. This is the argument that we can put forth, and this is the reason also. Right. We'll go for the next problem. Yeah. Example 9. The concrete block weighs 500 Newton. If mu equal to 0.3, calculate the tension in the cable when the bucket is raised and when the bucket is lowered. And of course, any thread has to suffer from tension only. In order to ascertain that it is tension, we can make a cut somewhere over here, and we will see there is an arrow that emerges, which is going out of a particular junction. That is the convention of T that we have, and T is going like this when the bucket is raised. When the bucket is raised, the movement will be like this, in this direction. Therefore, the frictional force will be like this. And there is a normal reaction which makes an angle of 75 degree with respect to vertical. There is a 500 Newton which also makes 75 degree with respect to this normal line, and here is T, tension in the wire. And if we solve this, and resolving the forces across the incline, we will get N going perpendicular to the incline minus 500 cos 75 due to this acting like this, 500 cos 75 acting exactly over this particular line, equal to 0. There are no other vertical forces, that is forces perpendicular to the incline, so N we will get to be 129.4. Resolving the forces along the incline, we have T going right, therefore positive, minus 0.3, and coming down, frictional force coming down, negative, minus 500 sine 75, the component of this particular weight which will be acting like this, exactly at this particular point towards the center of gravity of this bucket, and this is 500 sine 75. 500 sine 75, and this is the force which will be acting down the incline. So that also we have written, and we got T equal to 521.78. So when you want to raise the bucket, you have to the bucket has to resist, bucket has to overcome the frictional force. Okay, therefore it requires a bigger amount of tension in order to take it up because of this particular frictional force. This is the frictional force, okay, which will oppose the upward movement of the bucket, concrete bucket, friction, right? And on the other hand, when the bucket is lowered, the direction of the motion will be like this, therefore frictional force will be like this. So this is 0.3 n, this is 0.3 n, and this is 500, and 500 cos 30 will be acting like this, 500 sin 30 will be acting along the incline, and T is already parallel, that is tension. Resolving the forces across the incline, we have n minus 575 equal to 0, n equal to 129.4. Resolving the forces along the incline, we have 0.3 n, which is positive going right, T is going right, and minus 500 sin 75, and that is the component of the weight which will be acting in the direction something like this, collapsing. Of course it is collinear with D, it is collinear with D. This is 500 sin 30, the component of the weight along the incline, down the incline, sin 75. Okay, and we get T equal to 444.13, while for the other case we have 567 something, which is justifiably so. So okay, because this force 500 sin 75 will outsmart the frictional force, because it is showing a tendency along the incline. Okay, it is letting loose this particular bucket along the incline, so which will contribute for 500 sin 75. Right. Example 10. A wire parallel to the incline is used to connect two blocks of 500 Newton and 800 Newton if mu between the plane and the blocks are respectively 0.15 and 0.4, and here it is 0.15 and 0.4. This change in the frictional coefficient may be possibly owing to different kind of materials that exist at the interface of the incline and bottom of the individual blocks. Okay, and we have written the free body diagram. The direction of the motion is like this for both of them, and the common force for both the blocks is T, tension acting here away from the joint, away from this block, and tension also acting away from the block. And we have made a cut over here. Let us say T is the common force, and we will develop the analogy in solving this particular problem is we will develop a common equation involving T, and we will also develop an equation involving T, and we will equate those two equations only to get back as to what T is. Therefore, consider 500 block and sigma Fy equal to 0, that is perpendicular to the incline, N1, that is N1 over here, that is acting perpendicular to the incline, minus 500 cos theta coming down along this particular line. So N1 equal to 500 cos theta. So sigma Fx equal to 0 along the incline. If we resolve, we will have minus 0.15 N1 going up plus T, that is the tension force in the wire, minus 500 sin 30, the component of the weight going down the incline, and we will have an equation for T which can be stated to be 500 sin theta minus 75 cos theta. Similarly, in the same token, we will also develop a equation for T by considering the top block, that is the block which has already ascended some length of along the incline, or that is the initial position of this particular block. Anyway, here once again sigma Fy equal to 0, that is across the incline. If you resolve the forces, N2 is here going positive up, minus 800 cos 30, that is the component of the weight along the incline. This is actually 800 sin 30. This is 800 sin 30. Okay, this is 800 cos 30, the component of the weight. Since we are considering components of the weights along the incline and across the incline, this 800 Newton may be disregarded because effect of 800 Newton along the incline and across the incline has been taken. Therefore, we will never involve with 800 directly. Okay, the sigma Fy equal to 0, N2 minus 800 cos theta equal to 0, N2 equal to this one. And if we resolve the forces along the incline, we have 0.4 N2 going up positive minus T, which is going like this, negative minus 800 sin theta, and 800 sin theta, which is coming like this. And if we equate, we will get yet another equation relating T with theta, that is incline. So equating 1 and 2, as both of them relate T, we will equate like this, and we will add sin theta terms and cos theta terms. We will divide the r. We will bring cos theta down. It becomes tan theta, and 1300 is taken down, and we will get tan theta equal to 0.303. Therefore, theta equal to tan inverse of 0.303, that is 16.85 degree. So substituting this value in 2, and if we substitute the value of theta in any of the expressions relating T and theta, we will get back as to what tension is. So for this particular example, it happens to be 74.36 Newton. And here are two blocks that are connected by a horizontal rod. This is the horizontal rod, and are placed on two planes, one of them being inclined plane. If the weight of the block B is 100 Newton and mu equal to 0.3 at all the contact surfaces, I think it should be 1000 Newton. It is 1000 Newton, and mu equal to 0.3 at all contact surfaces determine the smallest weight of a block A for which equilibrium can prevail. A little understanding will show that the component of the weight along the incline is responsible for the movement. But anyway, the downward movement of this block will initiate the horizontal movement to the left as far as block A is concerned. And as soon as this jerk develops, there is a frictional force which will be developed like this, and there is a tendency for this particular block to move along the incline. So there is a force something like this, and this is already along the rod, and if you resolve this particular force along the rod, there is a force which is coming towards the rod, and there is also another force coming owing to friction towards the rod. So rod will be subjected to compression. Okay, therefore rod should be taken as compression. So the compression is represented by an arrow towards the body. Okay, right, we will write the free body diagrams for a better understanding. So this is going leftwards while this is coming downwards. So WA, FBA. Okay, F, that is the compression force towards BA. This is compression force towards AB, from A to B. This will represent the directionality as to where, as to how they are acting. So we have written the free body diagram of this, and this is also a free body diagram of the block. So considering free body diagram of A, that is A. Sorry, that is not A. That is not A. We will change that, and okay. Free body diagram of A means this is A, okay, as we represented in the figure. Yeah, this is A and this is B. Therefore, we should not get confused as far as the naming of the block is concerned. So here is 0.3 N1, okay, the frictional force, and here this is the free body diagram, and we can bring in relation between FBA, and we will develop an equation for FBA from this block and FAB from this block. We will equate both of them because FBA and FAB show the directionality, that's all. But anyway, compression force is same in the rod. So FBA equal to 0.3 N1, and if we resolve the forces vertically, it is N1 perpendicular to the incline minus WA that is the weight coming down. So N1 equal to WA, therefore FBA equal to 0.3 N1. We will denote it as 2. Considering the block B and resolving the forces along and across the plane of inclination, we have across the plane of inclination we have, okay, we have, right, we will once again go back, sorry, yeah, I'll go to the problem. Okay, this is over, this is also over, and here it is. Look at the free body diagram of this. This is coming down, therefore friction force is going up, and when you resolve the forces along the across the incline, we have N2 and 100 1000 N 1000 sin 35 sin 60, 1000 cos 60. 1000 cos 60 will be acting perpendicular to the incline, while 1000 sin 60 will be along the incline, and FAB should also be resolved because it maintains some angle that is 60 degree with respect to the line which is parallel to the incline. Therefore we have to resolve FAB also. When we resolve it vertically, it is FAB sin 60, and horizontally it is FAB cos 60. So we will solve this. FAB cos 60 plus 0.3 N1 minus 100,000 sin 60 equal to 0. Therefore upon simplifying, we will get an equation for N2. N2 is this much. So N2 equal to 1732.4 and 1.66 FAB. Now sigma Fy equal to 0 will give us the value of FAB readily. FAB is nothing but FBA if you go towards A. Now from equation 1, we will have N1 equal to FBA divided by 0.3. Therefore N1 happens to be 1625.8, and WA can be directly calculated because WA is nothing but N1. It's written over here, okay, when we wrote the free body diagram of this. Therefore with this, my dear viewers, we have completed part of problems on inclined plane. We will come out with still more problems on inclined plane, and if you have liked this video, kindly subscribe to this channel, and if you are done thus far, if you are not done thus far. So with this I say bye to all of you, and we will reappear again with next tutorial, that is tutorial number 4, which is continuation of friction problems, or the friction related problems, which the friction being developed on the inclined plane. So thank you.